Hey everyone, I hope all of you guys are doing good and staying safe. So in this second video of DevSecOps, in regards to ArgoCD with terms of deployment and GitHub Actions with self-hosted runners in terms of continuous integration, what we are going to take a look at in this video is we are going to take a look at the GitHub Actions workflow.ci YAML file. And in that YAML file, we have described all of the different steps in regards to what kind of workflow that we would like to have in terms of our continuous integration for this example Spring Boot application app that we saw in the previous class. And it's going to run on our self-hosted runner that is connected to this particular repository. So from where we left off in our previous class, you can see that we do have this self-hosted runner connected to our repository. And next, what we are going to do is we are going to run all of our CI steps onto this self-hosted runner. And once we run all of the CI steps on this self-hosted runner, then we are going to move on towards how to set up Argo CD in terms of CD and take a look at our CD setup. And then we will also take a look at, the entire setup once as to how we would work with it. So let's take a look at the GitHub Actions ci.yaml file. So every time when you work with GitHub Actions, you have to always remember that you can either bring your own hosted runners, or you can use GitHub's organization runners, or you can use GitHub runners for your respective repository. Or if you're working with GitHub Enterprise, they also provide runners. So these are hosted runners that run on GitHub's own cloud, which supports multiple different operating systems such as Ubuntu, CentOS. It also supports Windows based. It also does support Mac OS based. So if you are at a future point of time, developing a mobile based application for an iOS app or something like that, you can use the Mac OS, built-in hosted image that GitHub provides you to run all of your iOS builds. And if you are going to do some Android related mobile app development, you can go ahead and use Linux-based machine images for your Android application builds. In terms of using Fastlane, so I would highly ask you guys to take a look at Fastlane for mobile app CI/CD, which integrates with Jenkins, with GitHub Actions, and all of the other CI/CD tools in the market. In terms of taking your application's built code and publishing it to an internal registry in App Store and Play Store, or also to Microsoft App Center, depending on where you would like to, test your application. And this is particular to only mobile apps, right? So now let's go and take a look at our CI workflow based on GitHub Actions for our Spring Boot application. So always in GitHub, you'll have this folder called as .github/workflows. And within this folder is where you need to place your workflow.yaml file. So when I click on this ci.yaml file, let me just zoom in a little bit on this and let me show you as to what are all the things that we are doing, So we are calling this pipeline file or this workflow file a name, and then we are saying only on push to master branch, we would like the jobs to happen, we would like this pipeline to be triggered. And what are all the things that we are doing over here, So we are going ahead and running this job on a self-hosted runner. You could have multiple jobs where each and every job will run in parallel, or you can say needs as a condition where each and every job would run in a sequential manner depending on the other job. So for example, if you want to go ahead and do one build and then go ahead and do the test where the test depends on the build or something like that, you can go ahead and have a needs flag on your jobs in terms of running the first job and then running the second job. That's how you run it sequentially. But if you go ahead and have, sorry, so if you go ahead and have multiple jobs mentioned without the needs condition, then it's meant to be run parallelly. Okay. So over here, you can see that we have only one job that's doing our entire CI process with DevSecOps. So you can see over here in terms of the steps, we are using the checkout step first in terms of checking out our code into the self-hosted runner from GitHub. And then we are going ahead and adding some metadata by using this particular action. For all these actions, you can always Google about these actions and take a look at how it works, what are all the necessary parameters that needs to be passed to it. These are all GitHub actions that are published to the GitHub marketplace, which we can go ahead and use for all of our custom actions, or our CI workflow. And then we are using one DevSecOps tool called Sync, and Sync allows us to do SAST checks where we are going ahead and integrating, our pipeline with Sync by using the Sync API token. and which is added as a repository secret, which I'll show you in a moment, where you should add it and so on. And then sync tells me, in terms of how many vulnerabilities I have, how many lines of code, if I have any bugs in my code and so on. So this is more of, a feedback to the developer saying that, sync is going to give you SAST checks. So probably you can run this during your pull request pipeline, or you can run it on your master branch pipeline, as in how you would like to have it. But at the same time, it should be early feedback to your developer to iterate your DevOps cycle much better, And then we are going ahead and using Maven, not Gradle as our build tool. So we are using Maven to run our test cases by using Maven test command. And then we are using Maven package to go ahead and do clean and install, which removes the target directory and then installs all of the packages or dependencies mentioned in the pom.xml file, and then gets you a jar file based on the packaging type, with which you can go ahead and build your Docker image if you want to, or directly take that jar and run it somewhere. So that's being done in the Maven package step. But after building our classes and also our jar file in the target folder, we would like to run SonarQube. And SonarQube over here is nothing but Sonar Cloud because we are using the cloud version of it. And we are using a token in terms of connecting our repository to Sonar Cloud for it to do all of the scannings. And over here we have the organization defined, the host URL defined, the project key defined. If you want, you can define all of this over here, or you could have a sonar-project.properties file in your GitHub repo, which would automatically also pick up all of these properties. So in terms of getting access to Git, you need to also provide the Git token, which is nothing but your personal access token that you did in the previous video. So then once we are scanning Sonar Cloud, you can also choose to fail your builds over here based on a quality gate profile that you set up in Sonar Cloud. And that is very important because most of the organizations do have their own quality gate profiles, based on which they would like to fail the build. But just to keep it simple, guys, I haven't included quality gates, but you can also take a look at it when you work with Sonar Cloud. So it's that easy to connect Sonar Cloud to your GitHub repository using GitHub Actions. So in two places over here, you can go ahead and, convert this into a pull request pipeline. So what I would do is I would do the best pipeline ever by going ahead and doing a checkout stage and then doing my sync test and then doing my Maven test, Maven package and Sonar Cloud all in the pull request pipeline. So when I do all of this in the pull request pipeline, right when a pull request is created, that job is going to be triggered and my developers will get really good feedback at an earlier stage before it is merged to master branch or dev branch or test branch, or you may also call it as release branch and so on. And then after going ahead and doing Sonar Cloud in our project, we also went ahead and did Docker login to JFrog Artifactory. So right now, this is how JFrog Cloud looks like. We are using the cloud version of the Artifactory. And under artifacts on the left side, you also have a Docker repo, default Docker local repo. And within this, we have the Spring Boot example, repository, Docker repository, into which we have each and every image versioned in such a way based on the build number. So we are going ahead and logging into Artifactory, and over here the password is also something that comes from repository secrets. And then we are creating a Docker image. We are trivially scanning the Docker image, another DevSecOps tool over here. The first one was Sync, the second one was Sonar Cloud, and the third one is Trivi, where we are scanning our Docker image for any kind of vulnerabilities or any kind of CVEs and CWs, as how you call it. So if you want to go ahead and use an open source project, you can use Trivi. You also have Anchor Engine, you have ClarOS, you have Twistlock, you have Aqua, and as part of Aqua's open source, they called it as Aqua. I think it was called as Aqua Microscanner before, I'm not sure, but later they named it as Trivi. So there are so many Docker image scanning tools out there in the market. Even if you are using Docker for Windows or Docker for Mac, I think you do also get, some security aspects. Um, and other than that, one more thing that I wanted to mention is all of the hosted registries like Docker Hub or ACR, ECR, or GCR, they all have scanning inbuilt in terms of some of the open source projects that they have integrated. you know. So once you scan your Docker image, you can also choose to fail the build over here if you're having any critical vulnerabilities. So that's another really nice way to ensure that you have only really secure images going all the way to Docker Hub or where your registry is. So once you scan your image, we are pushing it. we are tagging our Git repository, and then we are pushing the tag to the Git repository, So an ideal pipeline looks something like this, where I want you guys to just concentrate only on the steps where you have checkout, and then you go ahead and run any kind of SAST checks. Then you test your code, you build your code, and then you do another SAST check, and then you log in. You probably, if you're working in a containerized environment, you do Docker images where you need to Docker login first, then build your Docker image, and then go ahead and scan your Docker image, push your Docker image, and then start your CD workflow. So generally, most of the CI/CD workflows work the same. So if you are familiar in writing Jenkins files or multi-branch Jenkins files or something like GitHub Actions in terms of workflows, it's all the same. Nothing is gonna change. Keep it as simple as possible, but as secure as possible also. So DevOps is not only just continuous integration, continuous deployment, continuous delivery. It also includes continuous security, which we saw right now. So you could also have load testing in your pipeline. You can have automation test cases run through, Selenium Grid also in your pipeline. Those are some advanced concepts that you can also include, but a base minimum pipeline looks something like this. So like I promised, I told you that I would show you the repository secrets. So when you go to settings of your repository, on the left side, right below actions, you have secrets, where you can see some of the secrets that we have added in terms of the sync API token, Sonar token, Git personal access token for for Sonar Cloud, and JFrog Artifactory password. So you can directly reference all of these secrets by just doing the curly braces, secrets dot, and then you can mention this particular secret name, and it's going to get the value from that respective secret. And how your pipeline is going to look like, it's going to look something like this, where you're going to be monitoring everything under the actions tab in terms of GitHub actions. And you can have like multiple parallel jobs running or multiple sequential jobs with the needs condition, like I mentioned. You can have a pull request separate pipeline. You can have a master pipeline. Something that I would like you guys to remember in terms of when you go for interviews and they ask you how your CI/CD pipeline looked like, you could say something like, we had a pull request pipeline, and then we went ahead and did all of our pre-checks like SAST checks all in our pull request pipeline to give yearly feedback to our developers. And then we went ahead and merged to master. And then you had a consistent build go all the way from master to all environments. So that's something that I would like you guys to answer if you are going for any interviews. I think they'll be really impressed when you say something like that. And one final aspect before closing off this part, is when you click on this build, that's where you get all of your steps. So you can see that you have a lot of steps mentioned over here, where GitHub Actions is intelligent enough to go ahead and download the Actions library at the start and then follow it up with all of your steps one after the other. You can also monitor this while it's going on, or you can go ahead and just leave it as it is and probably integrates something like continuous notification, where you get Slack notification from your pipeline as to what's happening in each and every stage. So that would be really good visibility into your pipeline. So having said this, this is how GitHub Actions work on the CI workflow. So stay tuned for the next video where we take a look at, some of the CD aspects. Okay. Thank you guys and have a great day. Please do stay safe and take care of your families. Thank you.